Welcome to Brain Vision.
So this question is asking us for the angular velocity as a function of time, the angular acceleration as a function of time, and the maximum, the time where the maximum, the maximum angular acceleration and when it occurs. So we are first writing the function for theta. So theta t equals omega t squared minus beta t cubed, where gamma equals 3.20 radians per second squared, and beta equals 0.500 radians per second cubed. At this point, to find our angular velocity rather, we find the derivative of the angular displacement. So the derivative of the angular displacement will equal the angular velocity function, and this is going to be 2 gamma t minus 3 beta t squared. If you were to plug this in, we have 6.4 radians per second squared times t minus 1.5 radians per second cubed times t squared rather. At this point, we can find the angular acceleration. So the angular acceleration is going to be equal to the derivative of the angular velocity. So this would be 2 gamma rather, minus 6 beta t. And again, we're simply deriving this with respect to t. So this would be 6.4 radians per second squared minus 3.00 radians per second cubed times t. So essentially, Wt is max when alpha t equals 0. So we can set this equal to 0 and say that 0 equals 2 gamma rather minus 6 beta t, and t is going to equal 2 gamma over 6 beta. And we can say that this is going to be gamma over 3 beta, or 3.20 radians per second squared divided by 3 times 0.5 radians per second cubed. And this is going to be equal to 2.133 seconds. So at that point, we can say that omega at t equals 2.133 seconds is going to equal 2 times 3.20 radians per second squared times t. So t again would be 2.133 seconds, and then minus 3, and then 0.500, and this would be times 2.133. This would be squared. And at this point, this unit here would be radians per second cubed. And at this point, we find that omega t at 2.133 seconds is going to be 6.827 radians per second. And this is going to be your omega max. So this is your answer, and it occurs at t equals 2.133 seconds. That is the end of the solution. Thank you for watching.